Hi, and welcome to our fourth video on topic 1. Today you'll need the note sheet that is 1-4, the commutative property of multiplication. And this is something we've been talking about all along, about how when we change the order of our factors, we still have the same product, however the meaning is different. So this is not super new, it's something we've been working with on each video. So let's take a look at this sheet. You will need the second note sheet in a moment that says 1-4 remix. So have that ready to go. And if you need to pause the video to grab it, please feel free to do so. So this property tells us that if you change the order of the factors, the product will still remain the same. This is sometimes called the order property, because we are talking about the order of the property. So either one, commutative property or order property, will work for us. So here we have 4 groups of 3. Remember, our multiplication symbol means groups of. It could also mean jumps of or rows of. And then today we'll talk about groups of. Our meaning is 4 groups of 3. And if we were going to draw that as an array, we would be talking about 4 rows with 3 in each. So go ahead and draw that array here. And then for repeated addition, we would have 4 groups down here with 3 in each. And when we add that up, 3 and 3 is 6, 3 and 3 is 6, and when I add those together, I get 12. So my product for each one of these representations would be 12. And finally, our jumps on a number line would be 4 jumps of 3. So I'm going to jump 3, and then I'm going to jump 3 again, and I'm going to jump 3 again, and jump 3 for the 4th time. And we end up, of course, with 12. So here's 4 times 3 represented all the ways that we've learned in 1-1, 1-2, and 1-3, where we have groups of, we have an array, repeated addition, and jumps on a number line. So now what we're going to do is take a look at what that would look like if we switched the order around. So now we'll take a look at our remix sheet. So here, instead of having 4 groups of 3, we're going to have 3 groups of 4, and we're going to draw that array as well with 3 rows with 4 in each. We already know our product is going to be the same, but now our images are going to look different. Repeated addition, 3 groups with 4 in each. Again, is going to still give us 12. And finally, we have our jumps on a number line, 3 jumps this time, but we're taking larger jumps and still up and up with our 12. Now, finally, we want to talk about how is 3 times 4 and 4 times 3 alike, and how are they different? This is a question you're going to see repeatedly throughout the topic, so it's a good place to review and even rewatch this video. We know that both equations are alike. Because they have the same product. Go ahead and take a moment to catch up. Both equations are alike because they have the same product. Finally, we know they are different because the meaning is not the same. In one equation, we have 3 groups of 4, and the other, we have 4 groups of 3. Take a moment now to pause the video so that you can fill this in. And one last comment on the commutative property. It's a very useful property in equations like 3 times 4 and 4 times 3. The representations that we have don't change a ton, but if you were ever to see a problem like this in the future, the meaning up here is 90 groups of 3. So imagine writing that out as repeated addition, where you would be drawing 90 of these lines and then drawing 3 on each of them. But if you know this property, and you can cleverly switch your factors around, and this becomes simply 3 groups of 90, a much easier equation to solve as opposed to those 90 groups of 3. So keep this in mind for the future. Although we know this changes the meaning drastically, if we're not worried about the meaning and just need to find the product, this property is a very useful tool to help us solve these equations more efficiently. Once again, thanks for joining us for topic 1-4, and we'll see you back for 1-5. Bye.